Great, thank you. Not more people here than I imagined at this stage of the evening, so thanks for hanging around. So, brief intro. I've worked in IT and information security the last 15 years. I'm currently working with C-Risk. We're recognised global experts in cyber risk quantification. So I've been working with them for the last 3 years, and I guess primarily today I'm going to focus on cyber risk quantification using the FAIR methodology. So I guess briefly, what is cyber risk quantification? I have a couple of definitions here, but from Gartner, ISACA, and our own definition. But the primary or key message, I suppose, to get across is that it measures risk and explains it in business relevant or financial terms. So one of the key benefits is to be able to communicate with the business teams in your company. I guess going by the last speech, you mentioned, getting that senior management buy-in, being able to speak their language is one of the key things, right? So briefly on FAIR, started in 2001. Jack Jones, he was CISO at Nationwide Insurance in the US. He started developing FAIR. 2013, he joined forces with the Open Group to create the Open FAIR standard, taxonomy and risk analysis. In 2014, published a book. Not too far. Published a book on FAIR. 2016, FAIR Institute was formed. It's a non-profit to promote the use of FAIR across the globe. So there's different chapters across Europe, Asia, US, growing all the time. It's a standard framework, kind of similar to CIS, NIST. Works well with all of these frameworks. It's used by a number of international organisations, and it's increasingly been included in regulations across the globe, including the SEC requirements in the US, DORA in the EU, and some German regulations as well. So what is FAIR? It's a standard taxonomy, provides a common language for communicating risk. That's very important that, it doesn't allow for misinterpretations or people, as we often see risk, there's different interpretations or definitions. So this has a defined taxonomy. It includes a methodology for modelling, analysing and quantifying cyber risk. It's complementary to other models, like I mentioned, like ISO, NIST, EBIOS. It's open source, vendor neutral. There's currently over 16,000 FAIR Institute members internationally, and 50% of the Fortune 1000 companies are covered in that. So FAIR defines risk as the probable frequency and problem magnitude of a future loss. So using this definition, the FAIR methodology sets out the steps of how we can do this. So the first step, and probably most important, is defining a risk scenario. Properly defining the scenario means everyone understands it, avoids confusion, and has a scope set out from the start. The next step is we quantify the scenario in the analysis phase. So there's two parts to this. The first is the likelihood, or what's called the loss event frequency, and then we evaluate the loss magnitude. I'll go into a bit more detail on these as we go. Final step is then using those results and presenting them back to senior management or whoever is needed. So why use CRQ? A lot of people, well, I guess a lot of people here have probably seen something similar to this heat map before when it comes to measuring risk, where, red, yellow, orange, green, what does it really mean, right? If senior management come to you and say, we have 3 red risks, which one's the top risk? Quite often nobody can tell the difference between them. So one of the key, moving on from that, key use cases for cyber risk quantification is communicating to the board and executive management. That's not to say heat maps are wrong, but using quantifiable data, we can better define what we mean when we say something is, high risk red. We have defined ranges or a defined timeline of when a risk scenario might occur and what that impact would be. It helps organisations understand information risk in business terms. Like I said, I've listed multiple use cases here. I'll go through a couple of them in slightly more detail, but these are probably the most common cases we see today. So understanding your third-party risk exposure, the impact of a merger and acquisition on your company, how material an incident would be, optimizing your cyber insurance risk coverage, optimizing your information security budget, facilitating regulatory compliance. Like I mentioned earlier, we're seeing increasing mention of quantifying your risk in regulations in the last number of years, and then choosing efficient risk reduction strategies. So often, the first question is, where do we start? We have all these risks, where do we start? So why do it? Kind of falls into 3 areas: understand, discuss, communicate, and decide. So I won't go through these in full detail, but the key first step is we want to understand what our main risk scenarios are and how much risk we have with those in financial terms. We want to communicate what activities would help reduce that risk the most, so we can prioritise control improvement or mitigation, and then decide what we're going to do about it. So that's can be optimising your cyber insurance coverage so that you have more cover for specific losses, or how we can communicate with our regulators to let them know we have analysed our risk and understand where we're vulnerable. So quickly, a couple of use cases. These are kind of like the questions we see and how CRQ can help. So, how can I get management to understand our top risks? By explaining the scenario in business terms, that gets you, first step there with explaining it, right? How can I explain the need for additional investments? Like I mentioned earlier, you can show the potential impact of a risk scenario, and by what you can do about it, you can show how that can reduce over time. How do I demonstrate the true impact of a data breach on your company? Everyone's worried about data breaches, but they often think it won't be too bad if it happens to us. Maybe they underestimate the number of PI records you have or something like that. So it can help you prioritise those risks so that you know which ones to focus on first. When it comes to third-party risk, this is obviously an increasing topic. We see it with kind of supply chain risk as well. What happens if one of our providers suffers an outage? We can quantify if that provider was gone tomorrow, what would the impact be on the business? What if they suffer a data breach? Increasingly there's shared data across multiple companies. And how do we determine our most important third parties? So by doing this kind of analysis, we can assess our third parties and decide which third parties maybe we shouldn't work with, or which one we or they need to implement additional controls to protect both themselves and us. And finally, the third use case we see often is cyber insurance coverage. So first question a lot of companies ask, should we invest in cyber insurance coverage, or how much should we invest? By determining the loss and the impact, you can determine how much coverage you need. If you have existing coverage, are you actually covered for the cyber events you think would affect you most? So how much of your potential losses would actually be covered versus, there's a lot of clauses in these insurance policies that exclude a lot of things that you think would be covered. And then, what type of losses affect us and what's our coverage level. So again, quite similar. If you understand them and map to your policy, you can see maybe where you're missing coverage or where you need to, you can maybe cut some coverage and add it somewhere else. So how to use FAIR? FAIR uses a value at risk model. It allows for the use of uncertain information. So we use estimated data ranges alongside levels of confidence. So for every figure or estimate we use a min, a max, and a most likely figure. The aim is to be accurate, not precise. By being precise, you can get a false sense of your results. So it's getting that a useful level of precision, as we say. But using accurate data when we determine those ranges is key. Once we have our ranges, and I'll go through the FAIR model itself in a minute, make use of Monte Carlo simulation, can run thousands of scenarios that will evaluate the estimated loss ranges. And then we can use probability distribution to look at potential future loss amounts. That gives us, our most likely and average loss amounts and likelihood. So expanding on what I showed earlier, the 4 steps. So we define our risk scenarios. Key things to know or to do to get this. Understand the business context and the value chain. So what's important to the business, how the business works. Doing workshops with key stakeholders across the business is key. If there's an existing risk register, all the findings of control gaps or issues, we can make use of that. This all helps us identify the crown jewels or assets. When it comes to quantification of the scenarios, like I said, we evaluate the loss event frequency, which is the likelihood of the scenario, plus the loss magnitude, which is the impact. First thing, this can seem daunting. First thing to know is you have a lot more data than you know. I'll go through some examples of that there, but in a company, everyone suffered incidents. Business teams have some idea if there's downtime in application, what that impact would be. If you've done disaster recovery testing, you know what your recovery times are. They're just some examples. When you use the taxonomy, that helps you break things down so you can explain it to the people you're meeting. Like I said, estimate a range of values for each type of loss, and then use Monte Carlo to calculate the annual loss exposure. You can then interpret, present the results. To do this, crafting clear risk statements or clear risk scenarios is key. You can tailor the message to the audience. So if it's senior management that you're looking for more investment from, if it's maybe another team that you want to highlight a potential security issue like we discussed, or like was discussed in the previous presentation, you can recommend actions, whether that's control improvements, mitigation, risk transfer, and then you can tie that back if there's a decision being made. So if it's the case of cyber insurance review, tie that back to the decision, do we need more coverage? Yes, no. Let's go on to that first step, defining a risk scenario. The FAIR model breaks this down to question, how much risk do we have from this scenario? So for every scenario, there's 3 key features you need. A threat agent, so that can be cyber criminals, it can be privileged insider, malicious, accidental, it can be an APT, nation state. Vector you can include as well, how they're going to access your asset. Phishing was mentioned a lot today, that's probably the most common one. Assets, so this is your crown jewels. It can be an application, it can be data such as PII, it can be intellectual property, and then that results in the loss event. And we would often, or the way we do it most of the time, is using the CIA triad. So it's either confidentiality, availability, or integrity. That's the loss event. So I just listed a brief example. Cyber criminals attack PII and database, and that leads to a loss of confidentiality. So using the FAIR taxonomy, this, hopefully you can read it, this breaks down risk as likelihood and impact. So as you can see here, you can go down different layers in the model. I'll go through each in a bit more detail, but you can see here it's a mixture of financial data, percentage likelihood versus a number. So when we look at likelihood, this is broken down. Loss event frequency start at the top level. That's the number of loss events you'd experience over the next year. This is made up of threat event frequency, which is made up of contact frequency, probability of action. So if you think contact frequency is the number of times a threat actor will come into contact with the asset. If we think about this in phishing, it's how many phishing emails make it through your email security system each year. Probability of action is maybe how many times employees then click on the link in those emails, just as an example. Once you combine those, you get threat event frequency, which is the number of times a threat actor will attack or attempt to cause harm to an asset. On the other side, we have vulnerability. So this is the percentage of attacks that will cause loss to be successful. And this is determined by threat capability. So this is how capable are your threat actors. Especially when we talk about something like privileged insiders, that's going to be pretty high because they have valid accounts already. They're well capable of doing it. Your resistance strength then is tied to how good are your defenses to protect you against these things. So one of the key things here is you don't have to start at the bottom. You can start at any of these levels depending on the data you have or need. Most often we often work at the loss event frequency stage. Companies either don't have some of the data that's here, maybe don't want to dig into it that carefully. Depends how experienced they are doing risk quantification. But I'll go through an example and we'll do it at the loss event frequency stage. On the impact side, again, like I said, this is the area where you have a lot more data than you think. So it's broken into primary and secondary losses. Primary losses are a direct result of the incident. Secondary loss is stakeholder reaction to the incident. So this is often your regulators, it can be shareholders are not happy, it can be if there was a PAI data breach, it can be those affected, launching a class action lawsuit against you. This is then further broken down into secondary loss event frequency. So how likely are they secondary stakeholders to do this, and then what that secondary loss magnitude is. So sticking with loss magnitude, there's six forms of loss. These are broken down into the most common primary and most common secondary losses. I won't go through the examples in detail, but productivity at a high level is, staff are unable to do their job. They come in, ransomware attack, all their endpoints are locked out, they can't do their job, companies losing money, paying people to do nothing. Your response costs are, forensics, legal, incident response teams, all those teams, both internal and external response costs. Response can also be a secondary loss quite often if you have something like I mentioned, if there's regulators or a court case, your legal teams are going to be involved due to that secondary stakeholder reaction as well. Replacement losses are tied back to ransomware. If your laptops or servers or anything are locked and they have to be replaced, this can be replacement cost. Secondary losses are primarily driven by competitive advantage, fines and judgments, reputation. So competitive advantage usually occurs if you have something like an intellectual property is lost, you have a new product coming to market that's been leaked, you lose that competitive advantage. Fines and judgments, regulators, can be contract penalties if you suffer downtime and your customers are affected. It can be contractual penalties. It can be people taking legal cases in the case of a breach. Reputation damage then is, negative perception. Will some of your customers leave you if you suffer a data breach? Will future customers stop or not use you because they don't trust you as a company, right? Once we combine these, you can see here, this is how we model the risk scenario. So you can see across the top we have our threats, assets, the loss event. You can see the loss event frequency side of the table, how likely that loss event is to occur. I've just listed some example controls at each stage across. The event occurs, you have your primary and secondary losses, and this is where your response controls, for example, come in to help reduce that loss magnitude. So just using an example, I know we're running over time, but again, I'll bring this back. In this example, a customer is concerned by the potential impact of a malware attack could have on their business, and has defined the scenario in the next slide. So their scenario is cyber criminals deploy malware via phishing, propagates to a large number, 20% plus of their workstation, resulting in a major incident, impacting the availability of their Windows workstations for 1 to 7 days. So like I said, that min-max range that we use that the whole way through. So we have our min and our max days of outage as well. So our asset is our employee endpoints, and in this case we mentioned Windows. Attack vector is phishing, impact is availability, the threat actors is cyber criminals with a high degree of capability. So I mentioned here, I think I forgot to say it earlier, but it's key to limit the scope of your scenario where possible. If you're worried about multiple threat actors, you should run multiple scenarios. The likelihood and impact is likely to vary. If you have multiple assets, again, it makes it more difficult to measure that when you spread across assets. So it's best to break it down into individual assets. And impact is the same, right? So estimating loss event frequency. You're primarily going to get your data from both internal and external sources. So some examples of internal sources is, either past incidents or near misses. In this company, they said they had a laptop infected 2 years ago, didn't spread any further, they managed to contain it. They had 3 phishing incidents that reached user mailboxes. Users clicked the link but didn't input anything in the last couple of years. What controls they have in place? They have EDR, they have MFA in place, they have strong user access controls. Known gaps or weaknesses. So, their patching SLAs are often not met. They don't do phishing simulation testing. So these are, say, internal factors we would gather from workshops or other data sources that we can use. And then we also tie that together with external data points. So that could be industry research papers, threat intel. There's lots of good research papers out there. I just mentioned one, Scientia. They do really detailed analysis on, broken down by industry, of how likely companies are to have cyber incidents. So, for example, we estimate the loss event frequency is a min once every 20 years, which is 5% chance. Most likely every 10 years, max once every 5 years. Then I think I forgot to mention as well, but down the bottom, it's always very important to document assumptions and your rationale and share that with the stakeholders. Especially when you're doing these interviews, if you don't include the source, it's very, very difficult to defend the data. And that's one of the key things with cyber risk quantification. When you're using data, it has to be defendable. It has to be backed up. So it's very important that if we make an assumption that something is 10% likely, here's all the data points we used. Some people might disagree with it, and that's part of the calibration at the end when you meet different stakeholders. But once you have that data that's there defendable, it makes things easier. So in this scenario, we're talking about malware. What losses are affected? Productivity is going to be affected. Employees can't do their job. Response to the incident. Placement of hardware. Secondary losses. There's likely to be some sort of response, maybe dealing with regulators or dealing with customers through contracts. Competitive advantage, in this case, no. Fines and judgments, in this case, no, because we're saying that there's no data breach. Reputation damage, most likely. If you're out of action for 7 days, some customers are probably going to move to an alternative, or if, for example, if you're an e-commerce website, someone's going to go and buy something somewhere else. Once we know what losses, we can, work with the internal teams to get that information. Some examples, how much would it cost per hour if staff are unable to work? What's the cost of our internal teams doing this? Do we have contracts with, for example, forensics companies to come in and help us? What's their costs? Hardware replacement, we know how much our laptops cost, so we know how much that's going to cost us if we have to replace them. Secondary response, we know how much our legal team or legal fees are. Reputation damage, we can speak to, some of our customer service teams, how likely they think our customers are to leave. If we lost 3 big customers, how much would that cost us? We can work with business teams to establish these ranges. Once we do that, we like I said, we run it using Monte Carlo simulation. We can get our loss per event and our likelihood. We can present. These are just some examples of how we present results. Bottom 2 are kind of, as we analyse multiple results, we can kind of chart that to show which ones are the most likely, which ones are going to have the biggest impact. You can go more detailed, like the one in the top left, where you break down how you can reduce the likelihood and impact by maybe implementing or improving certain controls. Other scenario examples, kind of broken this down through the CIA triad, like I said. Availability can be anything from a system outage, like I said, it can be a hardware failure, it can be malicious internal employee, maybe got fired and decided to shut down everything. It could be natural disasters, could be like a DDoS attack, taking down your e-commerce website. Confidentiality, multiple data breaches, PAI, sensitive customer documents, intellectual property, stuff like AI risk. So, we're increasingly seeing people are worried about what happens if staff upload data to a free AI tool like ChatGPT or something like that. All these things can be broken down and quantified. Integrity then is kind of your fraud, your financial fraud, using the likes of deepfakes and AI. Included can be data misconfiguration, affecting the quality of what's been used. AI training data. That's something else. As more companies use LLMs and develop their own AI products, what happens if that training data is compromised or if there's biases introduced to it. So then, just to summarise, there's lots of benefits to quantifying your cyber risk. Communicating risk in business terms, help you make data-driven decisions, help you prioritise your risks. It's an open source standard. Define taxonomy, I think they're key. Anybody can go on to the links at the bottom for the FAIR Institute or the Open Group, go in, read those, start using them. There's a great tool, I forgot to include a link here, called FAIR-U as well, FAIR-U, if you Google that if you want to use it. You can input the figures and it does the Monte Carlo simulation for you. Key things to remember: define and scope your scenario. Every scenario has to have a threat, asset, and an impact. Document all your assumptions and rationale so you can defend the data. If you're thinking about this in your company, you always have more data than you think. So it can seem daunting at the start, but the data is often there. It's just a matter of finding the right people to get it from. And it's about accuracy, not being precise. Nobody's coming out predicting you're definitely going to have a ransomware attack in 5 years. It's all about, this is the percentage you're likely to have it in the next 5 years. Doesn't mean that in 5 years' time it doesn't happen. It's wrong, right? It's estimation, not predictions. And I've linked there at FAIR Institute Open Group. You find lots of great information, more case studies, more detailed case studies there as well. And that's it. So. Have anyone any questions, or everyone's eager to get going?
Is there any open source platforms or and specifically that implements FAIR?
So like I mentioned, that FAIR-U is an open source training tool to kind of introduce people to FAIR. There's also I'm not a coder or anything like that, but there's repositories on R and Python that you can develop your own tool using those as well. There's a few other platforms that kind of give you free trials, but they kind of want to get you use more. But there's a lot of free Monte Carlo tools out there that you can include in Excel. That you can just input the figures in Excel. It'll run the simulations for you and use it that way. So yeah. Yes.
So the model is based on the assumptions as well as that something could potentially happen based on the quality of data that you have. So the better data, the more accurate the suppose data can be. What about for potential situations that could arise that you might not have data for. For example, maybe the company hires a junior developer in 6 months' time, they accidentally implement the vulnerability into the system, maybe by work code and SQL injection.
Yep.
A fair amount of actually have scenarios in place for stuff like that. You can analyze and say, well, under these circumstances, there's a 5% likelihood that you may expose your database or whatever. How does that work?
Yeah, I guess the question is, I'll try to summarize. Question is, where you're lacking data, how do you make those estimates? Yeah. So I guess that's the key feature of using the ranges for each part of the model, right? If the more uncertain you are, the wider the range is going to be. So if something's never happened before, it's often going to be a wide range. And when we run the simulations in the Monte Carlo analysis, it also provides ranges, min, max, most likely in its output. So it's never like a single figure, 5% chance it's going to happen. It's going to say 5 to 15%, most likely 7, depending on like I showed with the distribution curve, that's where the most likely figure comes. In regards where you say you don't have the data, that's where I guess the external data sources is good. There's a lot of, like, even if you're just looking for cyber incidents, there's a lot of great reports done every year on how many incidents are, so whether it's via phishing, whether it's, like you said, SQL injection attacks, all these things, there's lots of good reports out there. And they're usually done in a range as well, like 7 to 10% chance based on your industry or your company size, by revenue, etc., etc. So I would often recommend use those external data sources as a starting point. If you're unsure, then work with the teams inside to say, does this sound right? If not, why? It doesn't sound right because we have control X here that most companies don't have, or we have a basic control like MFA missing. Our likelihood is way, way higher, right? So if you're missing data, I'd always kind of start with the external to give you that base range. If, like I said, you could research for days and hours and the range can come in 1% each side, right? That's the joy of Monte Carlo. It gives you that, by running that simulation, 10, 20, 30, 40,000 times, it runs every kind of case in between, so it gives you that range in the results as well. Okay. Thanks, everybody.